We're doing 12.2, subdividing a segment in a given ratio. And as we probably have done in class, we need to figure out how a ratio relates to a whole value. So, for example, this question here says, on a straight highway, an exit for Arthur Avenue is at mile marker 14, the exit for Collingwood Road is at mile marker 44. The State Highway Administration plans to put an exit for Briar Street at a point that is 2/3 of the distance from Arthur Avenue to Collingwood Road. So where should the new exit be placed? Couple steps to this. The first might be to figure out what is the distance between Arthur Avenue and Collingwood Road. That's a pretty simple calculation to do. The harder one, though, is to figure out what does it mean to have something that's 2/3 of that distance. Well, we know that if we're going 2/3 of that distance, the remaining distance is 1/3, right? So our two fractions here we're dealing with are 2/3 and 1/3. And so the one that's 2/3 is all we need to do to multiply it by the difference here. So we'll see this here in an example. We can think of these as number lines. Number lines you guys are pretty used to using. So we have point A, Arthur Avenue, point C, Collingwood Road on our number line here. So we should be able to calculate the distance, do a little bit of subtraction. How far will Briar Street be, so point B, from Arthur Avenue, right? We know it's going to be 2/3 of that distance. 2/3 of 30 miles is 20. So what point is 20 miles from point A, or what is 14 plus 20? 34. Cool. So that was a relatively easy one. It's a little harder when we use those ratios instead of fractions. We have 2 points here. We have point A and point B, and we need to make a segment between them and then find the point that divides that segment into the given ratio. And the ratio they want is 3:1. And in order to have a 3:1 ratio, we need to think of what fraction of the whole this 3 is, what fraction of the whole this 1 is. The fraction of the whole value here, which is all 4 parts, is going to be 3/4. The other fraction will be 1/4. And we can kind of ignore the 1/4. If you want to think of it this way, back to the Collingwood Road example, you can think of point B here as being 1/3 of the distance from point C, right? Or 2/3 of the distance from point A. So it just depends on which end we're looking at. Usually we'll do the one on the left or just one of them, but it really doesn't matter. So we're going to treat this one the same way. Remember, number lines are just simple versions of the coordinate plane, right? Or coordinate planes are just fancy number lines. So we're just going in 2 directions here. We're going to number line horizontally and a number line vertically. So our first step is to, again, find the distance between the 2 points. So our rise and our run here. As far as distance is concerned, we want to keep it in just rise and run. We want to think of just horizontal distance and just vertical distance. We don't really care about the actual distance as far as using the distance formula. We can simplify it down into the horizontal, the x component distance, and the y component distance. And the run, or the x component distance, here is 16, right? It's the difference in the x's. The rise here is the difference in y's, which is 12. And then we can apply basically the same thing we did on our previous problem to these 2 values. So what is 3/4 of 16 and what is 3/4 of 12? 3/4 of 16 is 12 and 3/4 of 12 is 9. So this isn't our point. Keep in mind, this is not our coordinate. This is simply how far from point P, or how far from point A we're going to put point P. So we're going to go 3/4 of the distance from point A, and we'll put point P. We're going to go 3/4 of the distance from point A. We're going to put point P both horizontally and vertically, and those values come out to 12 and 9 respectively. So where's point A? Point A is at -8, -7, so we need to go and add those values to the x and the y value respectively. So 12 plus -8 is 4, and 9 plus -7 is 2. So our new coordinate is going to be at 4, 2. And if we graph it, we can use that to check. We can go, oh, is point P here, is that 3/4 of the way? Yes, and it's pretty easy to see when it comes out even, right? Because we can just go, oh, look at that, that's 1, 2, 3, and then finally 4, right? It's 3/4 of the way across. We'll do another one. Okay, we have points A and B. We need to divide that segment into a ratio of 1 to 2. So what is the fraction of the way that point P is going to be from that along the segment? And the fraction of the way along is simply going to be this first number here over the sum of both these numbers. So that gives us 1/3. We can graph it if we want. I suppose it helps. But we could also just calculate the rise and the run. The run is the difference in x's. The rise is different than y's. So that's 6 and -3. I'll put the graph up here. There you go. All right, and we know that point P is 1/3 of that distance, so we can multiply 1/3 times both the rise and the run. 1/3 of 6 is 2. 1/3 of -3 is -1. So we know point P is going to be 2 units away from point A and 1 unit away from the horizontally or vertically from point A. So we're going to add 2 to our x value of point A, and then we're going to add the -1 to our x value of point A to give a x coordinate of P of -2, a y coordinate of P of 3. So at -2, 3 is our point. And we can put it on here, right? We can go -2, 3 and see, oh, yep, that looks like it's about right. It divides it into divides it in 2 segments, but one is twice as big as the other, right? It's 1/3 of the way along. Okay, what can you conclude about a point that partitions a segment into a ratio of 1 to 1? It is in the middle. It's half, right? So you can just use the midpoint formula. All right, try these two real quick. So pause here. Supposed to be a Roadrunner. All right. The book also has sections where you're supposed to do this for a construction. You're supposed to divide a thing into a certain fraction or a certain length of the way along. And it wants you to do it using a compass. I think it's just a ton of work and it's not real practical. In real life, you just use rulers or measuring tapes if you're building a house or whatever. So use a ruler. You simply measure the distance from A to B, and then you're going to divide that by 3, and then measure that distance again from point A to point B. Pretty doable. You guys can handle it. But don't use the compass method. Feel free to just use a ruler. Okay, that's all I got. Thanks.